Hi, I'm Steve Mosier, and I'm a solutions architect at Cisco Systems. I would like to demo for you some code I recently shared on GitHub. What I shared was a solution for automating VPN creation between AWS virtual private gateways and Cisco CSR 1000B routers. It automates the building, the configuration, and upon need for removal, termination, and deconfiguration. Okay. It also has a component that manages the life cycle of the routers in the IPsec overlay. So this solution is shared on GitHub. As I said, there are two components. There's the standalone transit VPC web. So this is a web front end for that router lifecycle management. And there's a standalone transit VPC poller. So this poller reaches out and identifies where VPNs need to be created and removed. Okay, so let me go ahead and go into the VPC web here. And we see there's a README file with instructions for deployment in both Docker containers and local on your machine. So what I've done is I'm running Docker. I'm actually running two images right now. So we have the poller here and the web app. And the web app is actually forwarding port 8000 to 5000. 5000 is the green unicorn web server that is running within the container. And 8000 is how I'm going to get there through my local host. So I'm going to do that right now. So this is the program. It has a login. Since it is a container and it has a web interface, I went ahead and made a username and password to go into it. I didn't bake it into the code, but instead, you configure that as you deploy it in your environment variables. So this is actually the repository that I cloned, okay, down from GitHub. And there were a few things that I had to do. I had to go into the config file, and I had to, per region, configure my key pair names. So I have two regions that this is going to be active in, and I have to have key pairs for both of those. So that'll be used when I deploy routers for the initial configuration. And then for the poller program, here's a clone of that repository. For VPN configuration and deconfiguration, I need the same information. Okay, so here's the web again. And I go in, I make these changes. Just a few other interesting notes. For my regions, I need to know the Amazon machine image ID for the CSR 1000B routers. So this here is a BYOL version of 16.9.3, and so is this. It's a different AMI because this is in the eastern region. I've also got a few flags here. So there is something called an eligibility flag that I save on each instance of the router, and that lets the poller know whether that router is accepting VPNs or not. So I might have routers with different functions. Some might be encrypting traffic to cross direct connects, and I might deploy the number and type of routers that I need to achieve the throughput that I want across the direct connect. Well, if I do that, I don't want the poller program to start adding VPNs to those routers, because that would add on additional load of inter-VPC traffic. So you might want to mark those specific function for direct connect routers as ineligible for VPNs. Also, if I want to redeploy or do some other kind of lifecycle management, I might want to move all the VPNs off of that router. So if I mark the router ineligible, the poller will go ahead and automatically do that. But in this case, these AMIs are not hourly. They are bring your own license. So by default, I want them to come up and not be eligible. And that gives me an opportunity to configure my smart licensing or whatever licensing I need, and then I'll mark it eligible once it's ready to pass traffic. So once again, there's a few changes in the config file. I need to go ahead and edit my environment variables, such as my DMVPN password, my AWS keys, my web key. And then I have some environment variables also for the poller. In fact, it's very simple. It's just the AWS keys. So if you move this very lightweight program to another network, you would want to use the secure token service. So reach out to me if you need to do that. Okay, so we have the web and we have the Polar programs. I've already configured my environment variables for the web, and I picked Cisco, so that was an easy one to remember. I would pick something harder if this was production. And here's the way to manage the life cycle of the routers. But first, I'm going to click on Dashboard, because I've already deployed a cluster just to save time. And I have 2 routers. These are the original 2 that you would get when you deploy a cluster. They are the DMVPN hub next hop servers, and as well as their BGP route reflectors, which all of the new VPNs will pair with, and any other DMVPN spokes will end up pairing with. Okay, so I have the 2 routers, and they're marked as a specific cluster. So when I add routers, I can add capacity to a cluster, I can remove capacity from a cluster. So what is a cluster? Well, a cluster takes the place of having different VRFs. So as in the cloud, we know there's no VLAN tagging, there are no VRFs. You don't need to have different contexts. Ideally, in the cloud, you deploy just what you need to service what you need, and you right-size it to the capacity that you want. So here, what I would do is if I had a development cluster, I would deploy smaller instance sizes, and I would deploy them just to service the amount of bandwidth that I want from the cluster development. So sure, when I backhaul this, I might have some CSRs that are in cluster that have IPsec tunnels across direct connects back to maybe ASRs in the enterprise or in a colo. Well, that's where I would segment out development into development, and maybe there's another cluster for production. And maybe there's just, I don't know what other VRFs you would have had in your physical environment. Those would be clusters over here. All right, so I have cluster development, and another key concept is there was such a thing as the TVPC program key. So this program key could be set to anything, but here I have it as auto TVPC cluster member. Now this key, if it's applied to routers, say instances, this is how the Polar program and even the web program knows that these instances are at play. These instances are routers because this key is here. Then the cluster is the value of the tag. So this is the key of the tag. This is the value of the tag. And this is how, for instance, the Polar would identify VGWs. So I'm going to go to VGWs here and know that this VGW wants to be a part of that overlay network, for instance, the development cluster. So I'm going to go into a VGW that is attached to a VPC. So for instance, DevOps or IT gave the key value pair to some developers, and the developer of App A was given the proper credentials, which happens to be auto TVPC cluster and development. And now that my VGW, this developer's VGW, has this key value, now the Polar will identify that and configure VPNs to connect it to the network. There's another option that I can add, TVPC bandwidth. And this lets the developer request amounts of bandwidth. So these are in megabits per second. And I'm going to ask for 25. So this is important for the developers, as you could have a cluster of many routers, and the Polar program wants to use logic to make the best determination which destination router a VPN should be connected to. And that's based on load and how much bandwidth is being requested. So I'll show you that in a minute. So I'm going to go ahead and click on this. So now App A has the appropriate credentials to join the development network. So the Polar is running in 10-second cycles. So if I look at the main script file here, you'll see that per region, which are the regions from the config, like these two, and I could have others, per region, this is going to spin up multiple processes, and it's going to go out and run the polar function, which is all contained in this region polar. So I'll leave that to you to read through. But what happens is after the function is run in parallel to the different regions, there's a counter, and right now I have it set for 10 seconds. So in production, you'd probably set that to, say, 60 seconds. But just for this, I want it to catch any changes quicker, sooner than later. So if I go down to site VPN connections, I see that I have 2 VPNs that are coming up right now. So Amazon is building these VPNs, but it's already given me the configurations that I need. So I could pick, once you send the request, it sends you the data. In fact, if you go to download configuration, it'll format it for different vendors. But this program, it goes ahead and gets the information that it needs for its destinations and automatically configures the routers. So let me go ahead and go into one of those hub routers. And what we'll see is that I have 2 tunnels built for that one VPN. So when you configure a VPN from a VGW to a CGW, it actually creates 2, and the 2 different VPNs are anchored in 2 different availability zones within that VPC. So there's fault tolerance there. So we have tunnel 5000, tunnel 5001, and also I could see that I have BGP configurations. So for the VPN peers, I have 2 peers, and they're a part of the VPN spokes peer group. Has the proper remote AS, and we're going to go ahead and send a default route to those peers, and also we're going to send only that default route. So this prefix list out makes sure that VGWs only get default routes, so they're not overloaded. So you could have large route tables within these routers, but we know that the VGWs can hold, I believe, only still 100 routes. So they're only going to hold 1 because they're only going to go to a router, and then the decisions are made where things are going to go. So it looks like the tunnels have just come up, and BGP adjacencies have come up. So I can show IP, BGP, VPN, v4, all summary. And we see these are the autonomous systems, the 64512. These are the 2 different peers, and I've not received prefixes yet. So this is for app A. Let's go ahead and run this again. Okay, and now I have received routes. So we have 1 route from each. So if I show IP BGP VRF internal, show IP route VRF internal. Okay, so I have the route, and I have it from both peers, and the route is 1016. Okay, so now I can reach that VGW. I have the route. This router here, it can share it with every other router in the cluster. If there was a router a part of the cluster crossing direct connects, I could send this back to the enterprise. So now there is routing, and it is configured. So let me go back to this here, and I'd like to go to the dashboard. I'll go ahead and refresh the dashboard. And what we'll see, so once again, this is a very lightweight program. There's no database. So for the dashboard, once it refreshes, it actually goes out to AWS. It pulls all the information it needs. It gathers everything it needs to be displayed. And what we see is there is now a VGW that has that special key, the auto TVPC cluster member, and this is the cluster that's a part of. So due to that key being there within its tags, it shows up here. And we see that there are 2 VPNs that have been created. These are the VPN IDs. These are the EIPs of the routers, the CGW IPs, the VGW ID for it, and the requested bandwidth per VPN. So what we'll see with the routers is that 25 megabits per second was subtracted from the bandwidth that was available for these routers. So in fact, if I go back, I'll be able to see that. Let's go ahead and check that. Go to tags. And we see that the bandwidth is tracked in a tag. Okay, so that's that. Let me go ahead and go back to the life cycle of these. So let's say that I want VPCs in the GovCloud East region to be able to communicate across maybe a direct connect that's in the West, or access services in the West, or access other VPCs that are in the West and a part of the same cluster. Well, I'll extend my cluster. So I have an option. It's the only cluster I have built right now in AWS with that TVPC key. I'm going to go ahead and extend in the East, and then I pick the instance size of anchor routers. So I'll go ahead and hit submit, and then go back to the console over to the East region, and we're looking at EC2. So now I have 2 routers coming up, and these will be the anchors for the Eastern region. So now I'd like to go to a presentation and go over the life cycle of the routers. All right, as I said, there are 2 components to this program. There's the web front end that deploys routers, manages the life cycle, and then there's the Polar program that configures and deconfigures VPNs. You didn't see this, but there's an add cluster, and this is where I initiated the cluster name of development and deployed this in a certain region with certain instance sizes. So add cluster adds the BGP route reflector, DMVPN Nextop server routers. Right now, we're actually doing the plus region function. We're running it. And then 2 anchor routers will be moved into a region that we'd like to join. And they'll be also a part of the DMVPN backbone. We can add capacity. So if I've already got a cluster in a region, I can add more routers to it. So here I have 2, but let's say I want to add more capacity, maybe 2 more C5s. So that would be 4 gigabits per second of potential VPN traffic. There it goes. I don't have to select availability zones because the program makes the best decision. It finds out what zones are out there, what zones are actually available. It finds out where you have routers for that cluster already deployed, and then it spreads it out. So here's an example of I'm adding 1 more. So what's good about the ability to add capacity is you can take into consideration the bang for the buck of your different instances. You can do the math on performance versus cost, and you can deploy the best bang for the buck. Also with that, you can deploy with higher utilization, right? So you want fault tolerance. If you had 2 routers, you could only run the capacity of 1 router, right? Because if one went down, then the other router has to handle 100%. Well, if you had 5 routers like this, each router can handle 20% of the total capacity. Well, you can actually redundantly, you can go up to 80% of the capacity of all of these. So if there were 2 gigs each, here you have the ability to do 10 gigs. You could provision VPNs up to 8 gigabits per second. And if you lost 1 router, it would still work. So disable CSR is what flips that tag to say, hey, look, a router is ineligible. Here's an example. There's a VPN to a router. It was just marked ineligible, and now the Polar moves the VPN. Once I mark a router ineligible, it's available in the redeploy menu for redeployment. And redeployment gives you 3 things. I could redeploy as a larger instance type for more capacity, or maybe there's a new instance type. Maybe I want to upgrade the router. So through upgrading, I can go into that configuration file, change that AMI ID. Once I do a redeploy, it'll get the new AMI ID, and maybe that's an upgrade. So you shouldn't have to deal with bin files. You should actually just redeploy. And then a third benefit of redeploy is in the cloud, you don't have the visibility that you would have in a data center. In clouds, motherboards go bad, network interface go bad, a fiber could go bad if the cloud region's been around long enough. It's possible. And you could have some kind of performance degradation of your instance. Well, you really can't see it, and it would be horrible to troubleshoot it. So the idea is to take that concept from infrastructure as code of pets versus cattle and just blow away the problem instance and redeploy. And perhaps that ends up being deployed in a new rack or on a new server away from where the problem is, and then you could just be done with it. So redeploy adds a new instance, takes the EIP off of the old instance, deploys it on the new one, and deletes the old instance. So it's very slick, and then this works perfectly with even your next hop servers, because DMVPN spokes point to that EIP. And for BGP peering, they point to the tunnel across the EIP, so which is the DMVPN address. So this works for 3 different reasons. So here's enable. So once I disable a CSR, marking it ineligible, I can go to the enable and I can add it again, and then I can remove capacity. So, well, with this for subtract region, so you see the region on the left, if I clicked on this and I picked the cluster and the region, then everything's gone. And the same for the cluster. So after this demo, I'm just going to do that. I don't have to worry about anything. So now the cluster's gone. And that's the complete life cycle of the routers. So let's see how this is coming along. If I go to my extend cluster, it says deployed successfully. I'm going to go back to the dashboard and take a look at these routers that were deployed in the East region. Okay, so East region. So here's 1B and 1C, C5 larges. Nothing is connected to them now. And here's that eligibility tag. So right now it's false. So that gives me the opportunity to smart license these. So right now, I have a smart license account, and I went ahead and had 6 licenses added to it that I'm going to use for this demo. 2 are already in use, so these are those hub routers in Gov West, I'm sorry. And I want to license these 2 other routers before I enable them to service VPNs, because right now they're capped at 2.5 megabits per second. So what I need is I'm going to use, well, let me grab an IP. So here's .217 as the last octet. So I go into smart licensing. So this is on GitHub as well. And this goes ahead and configures routers for smart licensing. Let me grab the other IP. Okay, so this program can configure the registration for smart licensing and the deregistration. So what's cool about smart licensing is licenses are pooled. All right, so like I have the 6. Now, this is very cloud friendly because I could see what licenses I own. I could see who's using it. In fact, I can create other virtual accounts, and there's a whole organization that you can have when you buy licenses. So you see it, you see what's being used, and now it's not tied to hardware. So I can register for it, I can request a license, I can pull from the pool, then I can give the license back when I want to decommission a router or terminate it. So I can keep reusing these licenses, and it's very easy to do. So I have 4 in the balance. I have smart licensing here. I'm going to go ahead and register these, which is going to go out and pull some data from these variables files. So there's a variables for routers. So I'm going to have all the different routers that I want to configure for licensing with a certain feature and throughput right now. So these 2, it has the credentials I need. It has the keys, which are already in the keys directory, the IPs, and then there's the variables licensing, where this, I'm not going to show you because it actually has my token. It has my token, it has the feature set I'd like, and the throughput value. So this script is going to go ahead and fill in values from there. So obviously from license vars, I have a DNS server. In license vars as well, I have a contact IP, and I have a contact email address, and I have a destination address. So right now this is set to the default that goes to commercial Cisco. But if this was a standalone network or you didn't want to use that, you can use a satellite server, and I would put the URL to that server within my variables licensing, and that would get called and configured from there. Here's my token, and my token is connected to my account. So this Fed NSO has multiple tokens. I have one here, and that's the token that I put into my variables. So once that router reaches out to this portal with that token, it can access actually all of these different things here, but I'm going to request this license. All right, so let me go back. Okay, so all of that's been configured, and now all I have to do is run the script, not through the console. That would be a little extra work. Okay, so here goes the main. So it's reaching out to the routers. It configured the DNS and the URL, the token. Then it went back and it made sure that the router was registered, because it could take a minute, it's a transaction. Then it enabled the router for the AX feature package and the throughput that I requested. And then the same thing for the next router. So now if I go back to my smart licensing portal, I could see that 2 more licenses are in use, and I have 2 in the balance. So these routers are up now, and they're ready to service traffic. Now I should mark them eligible so that VPNs can be built to them. So let me go to Enable CSR. So that was 217 and 147. Well, actually, they'll be the only options here. So the only options you get to enable are ones that need it. Okay, so this is running out to AWS and changing the flag, the eligibility flag from false to true. So I'll be able to see that. So here's last octet of 217, and eligible is true. Okay, so this is eligible, the cluster's development. I can go ahead and let the polar do its thing. So I'm going to go to a VGW already connected to a VPC that I previously created. So this is VGW AppC. Okay, I'm going to go ahead and add that. I'm going to request, kind of frozen there, bandwidth. And we'll just say 55, could be anything. All right, so the polar is still running from that container, and within 10 seconds max, you should see a new VPN. Actually 2, there's 2 routers, they're both enabled. Okay, and here we go. So that's being deployed, and I could log into the router and look at the configs, but since I'm already in this one, what I will be able to do, once BGP is up, I'll be able to see the CIDR block for that VPC. So my VPCs happens to be test 10, oop, and the CIDR is 10.200.0.0/28. So once it's all up, I'll be able to see that even within the routers in the Western region. So that's convenient. But let's say I wanted to upgrade a router. To upgrade, I would use the redeploy. So here's the 217 again. I'm going to go ahead and disable 217. So disable CSR. And then I'm going to redeploy it with a larger instance size just to show you how easy this is. So 217. That flag is being switched from TVPC underscore eligible true to TVPC underscore eligible false. So now, once that happens, the VPN that was built to it will be deleted once the polar cycle sees that. So you see we have the 2 pending here. Yep, deleted. And now I'll have an option for a redeploy to that ineligible router. So I clicked on redeploy, and there it is. So now I could pick a different instance type. So before I do that, I'm going to go ahead and disable it. Or I'm going to go ahead and have it give its license back. So that was 217. Over to main. So I could use an argument for the command line. And I think I will when I redo this. But I'm just going to go ahead and run that script again with an action being deregister. And that's it. So it should be deregistered. There. Now only 3 license is in use. And I'm actually going to do the redeployment now. Okay, so here's the redeployment. So as in the slides, the new instance is being created. Okay, it's running now. It's down here. So it's going to go ahead and initialize, fully boot, get configured. Then the EIP from this other router, 217, or was it 147? Oh, well, it's East 1B. It stays in the same availability zone. So it's 217 will be moved over here. So now it's named 217, but it doesn't actually have the EIP yet. So it's something different for now. But once it fully boots up, then the program will move the EIP over. In fact, I could show you that while that happens. So this is the web. Here's a module for redeploy. Like actually moving the EIPs actually here at the bottom. Okay, so here's the main function. Takes in information from the old router and the new router, does its thing, and then let's remove the old router. It transfers the EIP. So this function down here actually does all that. And it's one of the last things to happen. So it transfers it, then it enables it, depending on the tag for your eligible, updates the tag. So it's going to stay false. Then it cleans up, uses a cleanup function for the old router. So let's see how far along this is here. Still initializing. That's still running. I guess just give it a minute. C5 2XLR. So I think that a 2XLR will even boot up faster than the other ones. I can go to the console. So this is still running. I'm going to go ahead and go in 8,000. See what the dashboard shows. Okay, so here's the new 17. CGW hasn't been transferred. It is reachable, so it's being programmed at this time. So this is almost done. Here, let's go ahead and move that, do a refresh. 217, they're both there. Okay, here we go. So the old 217 is being removed. And if I look at this one, I can see the EIP. Two things are highlighted. But 217 has now been transferred over. And we know that because we looked at the code. So now if I go back to smart licensing, I can change this to register. Look at my routers. I see I still have the that same global IP, and I'm going to go ahead and run this. Okay. Did it grab a license? Let's have a look at the portal. It did. Okay, so that's redeploy. So redeploy gives you, well, you see, while this is still deleting, the program is still kind of hanging there a little bit. It needs to finish cleanup. Redeploy allows you to change the instance type. It allows you to upgrade the operating system, and it's good for troubleshooting in regards to moving that instance to different hardware within the cloud. So here we see 2500. Here's the new router, and it's fully ready to function as a VPN termination, DM-VPN backbone connected inter-VPC connectivity router. So I'm going to go ahead and enable it. Before I enable it, I'm going to switch over to take a look at the VPN. So there's only one right now deployed. Okay, so here it goes. It's changing the flag, and we should be able to see a VPN being created. Oh, here it is. So we've got pending. All right. So here's one of our hub routers in the west region. And we remember that VGW in the east region's IP address, or CIDR block, was 10.200.0.0/28. So I should have that in my route table. And here it is. So now we have inter-region connectivity. If we had routers connected to a direct connect, they could get out. Now there's so many things that can be done. Full lifecycle management of the routers and the cluster, and how about that for automated VPN provisioning and decommissioning? So now I'm going to go ahead and just blow this whole thing away. Let me go back to I could give back the licenses first, but it takes a minute. I'm not going to do that right now. I'm just going to go ahead and go to remove cluster, and it gives me the only option that I have, and I can submit for the cluster. And this is going to get rid of all VPNs, all CGWs, all instances. The VGWs will still be there, and they'll still be tagged with whatever the developers added. So this could cause huge problems, right? If someone clicked on, destroy cluster, so within, 10 minutes tops, the whole cluster is going down, but then within 10 minutes, you could build a whole new cluster again. So that's the power of automation. And what we'll see here, I'm going to go ahead and show the EC2 instances. So the cluster is being destroyed. So these are my GovCloud East instances. They're being terminated, or they're shutting down. Here's the West being shut down as well. So everything is being removed. Right, and that's it. That really completes the life cycle of the routers. So I'm going to go ahead and add to the YouTube video the links to these different repositories. If you're interested in this, please let me know. I'd be happy to help you deploy something like this in your Amazon environment. And thanks for watching.